Earth might not even crack the top 10 most livable planets in the universe. Scientists have identified worlds with older stars, thicker atmospheres, and more stable conditions that could support life far better than our own. Today, I'm breaking down every planet that technically beats Earth at its own game, starting with the one closest to home, Proxima Centauri b. This is the planet everyone knows about. Our nearest neighbor, sitting just 4.24 light years away. It's the most studied exoplanet candidate we have. And it's also the worst one on this entire list. Here's the thing, Proxima Centauri b only receives about 65% of the stellar energy Earth gets from the Sun. But the real nightmare is its host star. Proxima Centauri is a red dwarf, and red dwarfs are violent. We're talking intense UV radiation and massive stellar flares that could straight up strip away any atmosphere the planet manages to hold on to. No atmosphere, no protection, no life, and it gets worse. The planet is almost certainly tidally locked. One side bakes in endless daylight, the other sits in frozen, permanent darkness, forever. Some models suggest powerful winds could redistribute heat along the boundary, making thin strips potentially survivable. But potentially survivable and better than Earth are two very different things. That's the irony. Proximity doesn't equal habitability. The planet everyone wants to visit first might be the one least worth visiting at all. But if the closest planet to Earth barely qualifies, wait until you see what's lurking 2,700 light years away. Kepler-69. C. Imagine finding a planet sitting in the perfect zone for liquid water, orbiting a sun-like star, with a year that's 242 days long. Sounds promising, right? Here's the problem. Kepler-69c might be Venus 2.0. Discovered in 2013 from Kepler Space Telescope data, this planet orbits a star about 2,700 light years away. The orbital period is close enough to Earth's to feel familiar, but the size tells a different story. At 1.7 times Earth's radius, Kepler-69c sits in this awkward no man's land between a rocky super-Earth and a mini Neptune. That means the gravity could be significantly stronger than what we experience, and a runaway greenhouse effect becomes a genuine risk. Think Venus, but bigger. But here's where it gets interesting. The host star is approximately 9.8 billion years old. That's more than double the age of our sun. If life somehow took hold on Kepler-69c, it's had billions of extra years to evolve beyond anything Earth has produced. Billions. The catch? Scientists generally can't tell if this planet is a paradise or an oven. The discoveries confirm, but direct observations of its atmosphere and composition are basically non-existent. It's the ultimate coin flip. But if uncertainty frustrates you, the next planet on this list finally starts giving us some real answers. Kepler-186f. When the media got hold of this planet in April 2014, the headlines were everywhere. Most Earth-like planet ever found. NASA discovers Earth's twin. Sounds exciting, right? Here's the thing, Kepler-186f is nothing like a sunny day on Earth, not even close. This planet orbits a red dwarf star about 500 light years away, and its radius is only 1.11 times Earth's, which is why everyone lost their minds. An Earth-sized world sitting inside a confirmed habitable zone. Multiple independent research teams validated that placement, making it one of the most reliably confirmed candidates we have. But here's where the media story falls apart. Kepler-186e only receives about 32% of the energy Earth gets from our sun. That means high noon on this planet would look like perpetual Arctic twilight. Not darkness exactly, but that dim orange-red glow you'd see during a winter sunset that never ends, every single day. Now, before you write it off, consider this. Red dwarf stars are by far the most common type of star in our galaxy. They outnumber sun-like stars by a massive margin. So if life can survive under dim, cool conditions like these, then planets like Kepler-186f aren't the exception. They're the template, the most common type of habitable world in existence. Still, dim and cold only gets you so far on the superhabitability scale. Kepler-62f takes a completely different approach to the problem. Kepler-62f. This planet has had 2.5 billion more years to figure things out than we have. Let that sink in for a second. Kepler-62f was discovered in April 2013, orbiting a star roughly 1,200 light years from Earth. At 1.41 times Earth's radius, it's bigger than our planet, but not so big that it crosses into mini Neptune territory where things start getting problematic. Its orbital period clocks in at 267.3 Earth days, placing it comfortably within its star's habitable zone. So far, solid candidate. But here's where it gets genuinely exciting. The host star, Kepler-62, is approximately 7 billion years old. Our entire solar system is only 4.5 billion. That means if life started on Kepler-62f at roughly the same pace it started on Earth, it's had billions of extra years to evolve, diversify, and develop complexity we can't even imagine. Earth needed about 3.5 billion years just to get from single-celled organisms to anything resembling complex life. Kepler-62f has had that timeline, and then some. Now here's the detail that caught me off guard. Kepler-62f isn't alone. It's part of a 5-planet system, and one of its siblings, Kepler-62e, is also a habitable zone candidate. 2 potentially life-supporting worlds orbiting the same star. That's incredibly rare, and it dramatically increases the odds of detecting biosignatures if we ever aim next-generation telescopes at the system. The one catch? It only receives about 41% of the stellar energy Earth gets from the sun. That's cold. But climate models show that a thick CO2-rich atmosphere could trap enough heat to maintain liquid water across the surface. Not a deal breaker, more like a different strategy. But if you think a 2-for-1 habitable system is impressive, wait until you hear about a star with 3 habitable zone planets packed so close together they'd fill each other's skies. TRAPPIST-1e. Imagine standing on a planet where you look up and see other worlds hanging in the sky, not as tiny dots of light, but as massive disks. Visible continents, visible oceans. That's TRAPPIST-1e, and it might be the most extraordinary neighborhood in the galaxy. Discovered in February 2017, TRAPPIST-1e orbits an ultra-cool dwarf star just 39.5 light years away. That makes it one of the closest candidates on this entire list. Its radius is 0.92 times Earth's, making it the most Earth-sized planet in its system. But here's where the numbers get wild. A year on TRAPPIST-1e lasts 6.1 days. Let that sink in. You'd celebrate your birthday, and then 6 days later, you'd celebrate it again. The planet orbits so close to its star that it completes a full revolution before most people on Earth finish a work week. The host star only emits about 0.05% of the sun's luminosity, but TRAPPIST-1e compensates by hugging it tight, still receiving roughly 60% of the stellar energy Earth gets, enough to potentially sustain liquid water. But the real magic isn't just one planet, it's 7. 7 worlds orbiting the same star, 3 of them sitting in the habitable zone simultaneously. The gravitational interactions between these sibling planets may actually help redistribute heat and stabilize climates in ways that a single isolated world never could. It's a built-in planetary support system. TRAPPIST-1 also has more combined observational data than almost any other exoplanet system. Extensive modeling, transit studies, and now early James Webb Space Telescope observations make its habitability assessments some of the most grounded we have. Scientists aren't guessing here, they're working with real numbers. But if TRAPPIST-1e benefits from having planetary siblings, the next entry benefits from something even stranger, an atmosphere that shocked everyone who looked at it. K2-18b. In September 2023, the James Webb Space Telescope pointed at a planet 111 light years away and found something that made every astrobiologist on Earth lose their minds: dimethyl sulfide. That's a molecule that on our planet is produced almost exclusively by marine phytoplankton, living organisms, and JWST detected possible traces of it in the atmosphere of K2-18b. That's a potential biosignature on another world, detected through direct atmospheric spectroscopy. Let that sink in for a second. Here's the thing, K2-18b was never supposed to be a candidate for life. Discovered in December 2015, it orbits a red dwarf star in the constellation Leo. At 2.6 times Earth's radius and up to 10 times Earth's mass, it's classified as a mini Neptune. Too big, too gassy, too weird. Nobody was looking at this planet and thinking, yeah, that's where we'll find biology. But the JWST data changed everything. Now, I need to be honest here. The detection is genuinely controversial. Some researchers argue the dimethyl sulfide signal could result from purely chemical processes with zero biology involved. Further JWST observations are needed to confirm or rule it out completely. This is not a done deal, but the possibility alone is extraordinary, because K2-18b represents something called a hiking world, a planet with a deep liquid water ocean beneath a thick hydrogen-rich atmosphere. No rocky surface, no continents, just ocean. And if life can exist in those oceans, then we've been thinking about habitability way too narrowly this entire time. The definition of habitable literally expands. But if K218b rewrote the rules, the next planet on this list might be the one that actually confirms them. LHS1140b. Picture a planet with no land, 0 continents, 0 mountain, 0 coastlines, just water, an endless ocean stretching in every direction deeper than anything on Earth. That's what LHS1140b might actually be. Discovered in April 2017, this world sits just 40 light years away, orbiting a red dwarf star in the habitable zone. At 1.4 times Earth's radius and a minimum mass of 6.6 Earth masses, it's significantly denser than our planet. That density is important because it tells us this isn't some puffy gas ball. It's either solid rock loaded with water or both, and JWST observations point toward the water world scenario. If that's accurate, we're talking about a planet covered by a global ocean, no dry land anywhere, just an entire world of liquid water, which means the entire surface is available for aquatic life to emerge. Now here's what separates LHS1140b from a planet like Proxima Centauri b. Both orbit red dwarf stars. Both sit in habitable zones. But Proxima Centauri b gets blasted by constant stellar flares that could strip its atmosphere entirely. LHS1140b's host star is quieter, way quieter. It's one of the more stable red dwarfs we've found, with significantly lower flare activity than most of its class. That means less radiation bombardment, a more stable atmosphere, and a much friendlier environment for biology. The host star is also approximately 5 billion years old. That's roughly the same age as our sun. Plenty of time for chemistry to do its thing. Plenty of time for life to not just start, but evolve. Researcher Dirk Schulze-McCouch, whose work essentially defines the modern superhabitability framework, consistently ranks LHS1140b near the top. Older stable star, temperate energy levels at about 46% of what Earth receives, and a potential global ocean maximizing biological chemistry. It checks nearly every box. But if you think a water world is impressive, wait until you hear about a planet that might have beaten Earth to habitability by billions of years, Kepler-22b. This planet should be the crown jewel of exoplanet discovery, and in a lot of ways it is. Kepler-22b was confirmed in December 2011, making it one of the very first exoplanets ever found sitting inside a habitable zone. It orbits a Sun-like G-type star 600 light-years away, with an orbital period of 289.86 Earth days. That's almost identical to an Earth year. Its host star is roughly 7 billion years old, making it significantly older than our own sun, and the planet receives about 1.11 times the stellar energy Earth gets. Not too hot, not too cold, just slightly warmer than us. On paper, this thing is perfect, but here's where it gets frustrating. Nobody actually knows what Kepler-22b is, and I mean that literally. Its radius is well measured at 2.38 times Earth's radius, so we know how big it is. The problem is its mass. Estimates range from 2.4 Earth masses all the way past 100 Earth masses, depending on what scientists assume it's made of. That's not a small margin of error. That's the difference between a rocky super-Earth covered in breathable oceans and a crushing gas giant with zero solid surface whatsoever. Think about that for a second. We've known about this planet for over a decade. It orbits a sun-like star. It has a nearly Earth-length year. It sits in a warm, comfortable, habitable zone. And after all that time and all that study, scientists still can't tell you whether you'd be standing on solid ground or sinking into an endless atmosphere of compressed gas. Kepler-22b is the universe's most frustrating mystery box. Everything about its orbit screams habitable, but until next-generation telescopes can directly observe its composition, the most fundamental question remains completely unanswered. We don't know what it is, and the next planet on this list has a similar problem, but with a twist that makes it even more interesting. KOI 5715.01. This planet wasn't found by accident. It was found by researchers systematically combing through the old Kepler data, looking for something everyone else had overlooked. And they found exactly what they were hunting for, a world that scores higher than Earth on superhabitability scales. KOI 5715.01 sits roughly 2,964 light-years away in the constellation Cygnus, orbiting a K-type orange dwarf star with a period of about 190 Earth days. Its estimated radius comes in at 1.77 times Earth's. Bigger, but not too big, the sweet spot. Here's where it gets interesting. This planet receives approximately 1.08 times the stellar energy Earth gets from the Sun. That's almost identical to our insolation. Not double, not half. Almost exactly the same, with just a tiny bit more warmth. The host star itself is a K-type dwarf, cooler and smaller than our Sun, which means it burns slower and more steadily over billions of years. That combination of size, energy input, and stellar stability is precisely what superhabitability researchers have been looking for. But the real story here isn't the planet itself. It's how we categorize. In 2020, a landmark study built a systematic framework for ranking superhabitable candidates, applying criteria that specifically prioritize planets slightly larger than Earth receiving slightly more energy from long-lived K-type stars. They combed through the Kepler catalog and flagged KOI 5 715.01 as a top candidate that nobody had thought twice about, a planet potentially better suited for life than our own, hiding in data we already had. Now, honesty check. The evidence here is thinner than older entries on this list. Zero atmospheric data exists. Independent confirmation is still accumulating. We know the orbit and the star, but we don't know what this world is made of or what seats on its surface. That said, KOI 5 715.01 represents the frontier. This is what cutting-edge habitability science looks like. Refined criteria, systematic ranking, and candidates that challenge our assumption that Earth is the gold standard. But there's one planet on this list that might challenge it even harder. Kepler 442b. Every planet on this list has something going for it. A perfect size, a stable star, the right temperature, but none of them nail every category at once. Kepler 442b does. Discovered in January 2015, this world orbits an orange dwarf star about 1,200 light years away. And here's the thing most people don't realize. Orange dwarfs might be the single most important type of star for life in the entire universe. They burn cooler and more stable than our Sun, lasting tens of billions of years without the violent flare outbursts that plague red dwarfs. They're the Goldilocks stars that nobody talks about, and Kepler 442b orbits one of them. The planet itself sits at 1.34 Earth radii with an estimated mass of about 2.3 Earths. That's the theoretical sweet spot. Large enough to hold a thicker, more protective atmosphere. Large enough to sustain geological activity and a magnetic field for billions of years longer than Earth can, but not so large that gravity becomes crushing or the planet balloons into a gas giant. It's exactly where scientists want a super habitable world to be. Its host star is approximately 2.9 billion years old, younger than our own Sun, but here's the key. Orange dwarfs live far longer than Sun-like stars. That means Kepler 442b has billions upon billions of years still ahead of it. If life ever started there, it has an almost incomprehensible runway to evolve, diversify, and become something far more complex than anything on Earth. It receives about 67% of Earth's stellar energy. Not too hot, not too cold. Safely away from runaway greenhouse territory and nowhere near freezing over. Multiple independent habitability studies, including Dirk Schulze and McCuch's foundational superhabitability research, consistently rank Kepler 442b at or near the top of every known exoplanet candidate. It doesn't dominate any single metric. It scores exceptionally across all of them simultaneously. Size, stellar stability, orbital position, energy received, every box checked. But here's the bittersweet reality. We have zero atmospheric data. A 1,200 light years away, direct study is essentially impossible with anything we currently have. We may never reach it. We may never even confirm what's there. But on paper, based on everything science currently understands about what makes a planet suitable for complex life, Kepler 442b is the closest thing to a theoretically perfect world humanity has ever found. And it's just sitting out there, waiting. If you enjoyed this video and want to see more, click the video on the screen now.